All right, meeting is in session. All right, so starting, so let's do a quick recap of what we did yesterday, so that we can, that'll be useful. I'll skip these. So we looked at what a query is and how a typical engine translates a select statement into relational opcodes and eventually runs the optimizer to generate custom opcodes or rearrange the order in which operations are performed to make sure that the best plan is used to satisfy a query. In this slide, we covered the 9 opcodes. I didn't go into the details of each one of them because that would go for hours. But they are fairly straightforward, and the design doc that I wrote covers them in detail. So one question we could ask ourselves is, which of these opcodes have to be supported by VTGate to support the full SQL syntax, right? If you ask that question, anybody has a volunteered an answer for it?
For which opcodes need to be supported in VTGate to support?
Yeah, what, like, because VTGate has database engines underneath.
Yeah.
Right? Which opcodes would VTGate need to support to basically satisfy or to be able to satisfy any query that you can throw at it?
Well, so let's see. Definitely sort, right? If we're gonna get rows from different shards, they might be sorted individually from the shards, but then we might need to sort them after that.
Yeah.
We might need to limit after that the same way. You know, if you limit 10 on 2 shards and then you have 20, then you still need to hopefully sort, then limit. Merge, definitely. I mean, that's one of the BT only opcodes. That's not like a MySQL thing. I mean, maybe, I don't know, in the case of partition tables or something.
It's a union, by the way. Merges, that's what it is.
Yes. Well,
Yes.
even for like a scatter, right? You need to merge.
Oh yeah, scatter. I don't think merge means that actually. Here, merge actually. Oh, scatter too. Yes, you're right. Merge is works for scatter. You're right. You're absolutely right.
So select seems like it should be handled by pushing down. Let me think.
Not if your expression involves not always, because your expression may involve data from multiple shards, right?
Yes. Yes.
And also, if by the fact that you said that aggregation, aggregation has to be done by VTGate in some cases.
Yep.
Anything that you do, you have to do on top of aggregation, which is a select.
Yes, which means that so filter, if I am remembering these opcodes correctly, filter handles both where and having. So if you're going to do having, then filter needs to be done in VTGate, and as covered last time, join
and left join are totally necessary. In other words,
everything.
8 of those 9 opcodes are needed. That's basically the correct answer. So eventually we'll have to basically, what it means is that eventually VTGate has to become a full database engine.
Yeah, which I was wondering, I mean, certainly, like, the design decision happens in a different order. But if you had known, would you have started out just with a database engine? So maybe started out with the front end of MySQL.
I didn't understand the question.
Well, okay, yeah, sorry, it was a little roundabout way to ask it. If you knew at the beginning of building Vitess would we have used MySQL at all? No. We could have. I mean, it seems like we do have a perfectly good SQL engine laying around called MySQL. It's the same dialect.
Oh, whether we could have used MySQL at the VTGate layer?
Yes.
We have talked about that. And we honestly don't know if it'll pay off.
Sure.
Yeah, so that is that option is has been there and will probably be there. The only question is, will it pay off? Because the main difference is that will work only if a single VTGate node can handle your result. So that's one problem, right? If the work is big enough that a single VTGate node cannot handle it, then you have created a bottleneck right there already. So if you have 10 billion rows that you need to scan, and you pass, and at that time you want to, the very fact that you sharded your database means that you don't want all your data to go through one node, right? Because then you defeat the purpose of sharding.
Yeah.
So we don't know if it will pay off for all use cases. It will definitely give us a quick head start, because if I have only a handful of rows and I have to perform complex operations with it, I can outsource it to a local MySQL engine and it will do the work for me.
Yeah.
But when it becomes larger scale, where you have to actually deal with an indefinitely large size of data, it will probably not scale.
Sure.
Have you guys thought about multiple VTGate servers talking to each other and creating a cluster of VTGate?
Yeah. So that is the alternate approach, which is
right.
The Hive approach that we talked about, where if you get a complex query, then you convert it to a MapReduce job.
Right.
And then multiple VTGates. Then you have the parallelism that you need to be able to process that volume of data.
Mm-hmm.
So I think so maybe I guess the correct answer is we could get good mileage by using a local MySQL because it will be more functionally complete in terms of what it can do. But it will fall apart as soon as your data size requirements exceed the size of a single node. So in the long run, it may not be worth it, because substantial work would have to be done to make VTGate use a local MySQL, and then eventually you'll have to throw it away because it won't work for all use cases, right?
I think the other issue that I could see is failovers in that MySQL. If we start using MySQL at VTGates and VTGates have any kind of failovers, we need to maintain failover scenarios for those MySQL instances as well.
Yeah, in this case, we are actually using MySQL not as a storage engine, but just as a compute engine.
Okay,
got it. It may actually not even have a disk. It doesn't need a disk.
Right, okay.
So we are just like, for example, if you want to sort something, you give it to MySQL and say, sort these rows, right? So that's, it's kind of weird, but it could work. But then the fact that we are using a storage engine for doing computational work may not be the best use of resources, because what if MySQL says we need transactions, you need to commit your data, I need to persist it in some disk, and so it may defeat the purpose of what we are trying to do. But we have considered the option. Looking at how deep it can go, we kind of said, okay, let's leave it aside, keep it as an open possibility, but for now, let's just make VTGate work. Let's just add the functionality in VTGate itself. So coming back to these primitives, the next question is, if all these 8 aggregates are needed, how is it that we are able to cover so much ground just by using route, join, and left join, right? And the answer to that is simple. It's because route is capable of doing all 9 operations. Basically, to a route, you can give any complex query, and it can do the job, right? So route is technically capable of doing all 9 operations, except that it can do it only on a subset of the data, which is a single shard or a single unsharded database. So and that's the reason why we can cover a large amount of ground in terms of query diversity, just with route and joins and left joins. And as I mentioned before, the downside of using route is that even though route can perform all those 9 operations, you cannot give it relational instructions. You have to give it SQL. And that's the reason why we have to retain the original representation so that we can pass some of that along into the route so that when it does the work and we look at the queries that it's executing, we know where it came from. So that makes sense?
Yeah. Question, Sugu.
Yeah.
So when it comes to a transaction at VTGate level, basically your inserts or selects or whatever are mostly clubbed into a begin and a commit block.
Yeah.
So does VTGate need to have special knowledge about those things as far as SQL parser goes, or how does it handle that?
So the way transactions are handled in VTGate, so the VTGate itself does not keep state. They're all stateless.
Right.
So the only thing that VTGate, so the transaction, or what we call it, the session information, is actually stored on the client side, and it's exchanged like a cookie.
Okay.
So when you do a begin transaction, there is a session created that the client that VTGate updates as it starts transactions with VT tablets, and then that information is sent back to the client or when the instruction is completed.
Okay.
So you can basically start a transaction with one VTGate, continue it using another one.
Oh, okay. Oh, okay, okay, okay. Got it. Got it.
So VTGate itself does not the only intelligent thing it does is if it sees that it's already opened a transaction with the VT tablet, it reuses that. But in terms of DMLs, it just sends the DMLs to VT tablet, and VT tablet does what is needed.
Okay, so it's completely asynchronous operation as far as VTGate goes for any transaction.
Correct. Yeah.
Okay.
Yeah. It does have to do some things. If it's using lookup, if there are lookup indexes and there is a delete, it needs to know that it has to delete those entries. So it does that kind of work, but nothing related to transactions per se.
Okay. All right.
I guess the other thing I should mention is VTGate is also a 2PC coordinator. So if you've enabled 2PC and you do a commit, then it does perform the 2PC coordination.
Okay, got it. Cool. Thanks.
So back to here. As actually this particular presentation doesn't really cover DMLs and transactions because compared to the complexity of this, that part is actually pretty simple. Because most DMLs are just sent to the VT tablets, and that's about it. Right? We already have the restriction that a DML should only be one key space ID. And because of that, most DMLs are a relatively easy problem to solve. For now, Flipkart is actually working on supporting multi-key space ID DMLs. So when that comes, that part will get complicated.
Okay, all right.
It seems like that's it's not super necessary, right? I mean, if you can open up a transaction like a two-phase commit, do
Yeah,
do
yeah.
all your single key space DMLs, and
Yeah.
and then like commit. That seems like why
Pretty much, yes. You're right.
even bother with making it that much more difficult.
Yeah, yeah. The power of a relational engine comes mostly from its select. The DMLs are usually not that complicated. Usually. But people do tend to go crazy when they see, and you do see join updates and stuff, but they are really, really rare.
Yeah, if I recall, we have an open line item on this query compatibility epic.
Yeah, I think I saw there's an update join, right? A join update.
I think it's a delete.
A join delete, yeah.
Yeah.
Yep, it does happen. But it's also true that those things can be easily rewritten.
Oh, for sure. Yeah. I mean, like if we run out of time, we'll definitely just push back on the query writers to say like, no, that's what a transaction is for, even.
Yeah, but the counter argument is that, well, if the application can rewrite it, VTGate can do it too, or VT tablet can do it too.
Yeah.
Which is kind of the feature request, and that's the reason why I haven't pushed back on that feature request. Because I think there's value in VT tablet doing that rewrite, because then the application doesn't have to do it. And then it'll work on any application that sends a query of that complexity. Cool. So we looked at what a traditional relational engine would do to handle queries, and we looked at why that will not work for us because of the fact that we are architecturally, we have some architectural similarities, but there are some fundamental differences, especially the fact that what's underneath is a full database. So because of that, we have to do things a little differently. And the big difference being that we try to preserve the original query, because there is a very high likelihood that the query can be sent as is to one of the VT tablets. In that case, we want to keep the original representation and look at that point. Basically, we want VTGate to act like a router, not like an engine. So that's basically the goal here. And what else did we look at? We looked at what is a broad strategy about routing, which is try to identify queries that have, if a query comes and it's only one database, just send it there. If it is more than one database, break it up such that each subpart addresses only one database, and then do the stitching at the VTGate level. And finally, here we are. So we are now going to run through some use case scenarios. And so basically, if we understand this, I think we will understand pretty much how VTGate should handle each query and what it needs to do. So basically, this is a precursor to explaining how VTGate works. So here is a query. There is table A. And obviously, if you use a column name called ID, you assume that it's a sharding key, right? ID is always the sharding key. So here is a select that if we send to VTGate, what would it do, right? It's basically select a bunch of columns from A where ID equal to certain value. So the answer to this is very simple. Well, ID is a unique sharding key, so just look up which shard that key is in, and then send the query to that shard. Make sense? So here, you could. It's very obvious. It's very easy to intuitively explain what should happen here. So obviously, yeah, it's a sharding key based where clause, so obviously it should go to that shard. But the underlying principle that we are using is what relational engines use is what does an index do for you in a relational database? So if you ask that question, basically an index tells you that given your where clause, you do not have to scan all rows of the table to satisfy a query. If you scanned only a subset of these rows, you will get the same result. And the index basically gives you that guarantee. So basically an index, what an index does, it basically restricts the number of rows that you need to scan in order to produce the same result that you would have otherwise produced if you had scanned the full table. And basically the same principle applies here. So when you said, when we look at a.id equal to id, what the Vindex tells you is that in order to satisfy this query, you only need to scan this one shard. And it will produce the exact same result that you would have otherwise produced if you had scanned all shards for this query. Make sense?
Yeah.
The reason why this is important is because in the intuitive case, it's very easy to say, oh yeah, it's a single shard query. But when queries become more and more complex, the intuitive answer will not work. But if you go back to the root of the question, which is what are the rows that need to be scanned in order to satisfy this query, that is actually an easier question to ask to make a decision on where a query should be routed. All right, so here is another one. Same select, except that this time it's an in clause for the list of IDs. So in this case, the query could go to multiple shards, to more than one, right? Because one ID could be in shard 1 and the other ID could be in shard 2. So this is actually an in clause route, which means that if I see this query, I go ask the Vindex, okay, here are my inputs. Give me the list of shards. Give me a mapping, actually, for each of this input, which shard it belongs to. Right? And then I use that mapping to say, okay, for these values, I need to send, I build a separate query for each shard. So if my list has 1, 2, and 3, if 1 and 3 in shard 1 and 2 is in shard 2, then I will do select where ID in 1 and 3 to shard 1 and ID in 2 for shard 2. So this is basically a smart route where if you have an in clause and there is a list, it actually splits the list into smaller parts and then sends those individual queries to different parts of the database. It's actually a trivial, minor optimization, but it could pay off because especially if you're trying to fetch me 2,000 items, right? And they are all over the place. And if you have like 200 shards, then each shard gets actually a smaller query as input. Cool. The next one, select from a table where a column equal to certain value, right? So what this means is that this is actually an unsharded column. How should this query work? So this query, we don't know, right? There is no Vindex information for this, which means that rows could be found in any shard.
Sorry, why do you say that it's an unsharded column?
Doesn't specify ID.
Actually, unsharded column is incorrect. It's actually the column does not have a Vindex. There is no shard. Yeah. This column is not a sharding key.
Yes, that's okay.
Yeah, sorry. Unsharded has a more specific meaning. So it's a column that doesn't have a sharding key, which means that this value could be found in any shard. So what this means is that we have to send the query to all shards. So this is what we call as a scatter query. And there is actually another question that you have to ask yourself. There is danger in scattering a query. You can scatter a query only if there is no data dependent. I don't know how to state it. So there should be no data dependent. Basically, the way you have to decide that a query is scatterable is if you ran this query on a subset of the data, and ran that same query, that query that runs on the subset of the data does not require to go outside that subset to satisfy the query. I don't know if I explained it correctly.
Maybe it's something like you don't have a count star, that kind of thing.
Exactly. So basically, if the query does not have external dependencies. So if you ran the query on a subset of the data, that is the only data that it needs to satisfy that query. It does not have to look outside that subset.
So it's like intrinsic rather than like...
Correct, yes. So this is basically another property that we look for. If that property is not satisfied, then you cannot scatter a query. And the best example is if, for example, you have a group by, right? If you had a select count of a.call, count star from a where call equal to call, then you cannot scatter the query, because when you scatter the query, you're going to get as many results, but you want only one result, right? So the dependency actually goes beyond what is intrinsically present in the query itself. You need to actually have all the data with you to be able to satisfy the query.
So, but this is just a restriction on current day Vitess. I mean, there's no... I mean, right now, right, we don't do any kind of complicated merge.
Correct, yeah.
Right? So like, but it's certainly like a theoretical possibility that in the future we scatter these things, and then we know that
yes,
we do a certain kind of merge, like a merge sum or a merge average, or whatever.
Yeah.
I mean, we have none of these kinds of like operators in place as is.
Yeah.
But yeah.
So I'm basically describing the scatter route primitive in this case. So the scatter route primitive, what it does is send your query to all shards and just return the results as they come. And so if there is cross-shard dependency that is required to be computed beyond that, then yes, VTGate has to do it. Or if there is the other thing that you cannot scatter is if there is a join inside it that actually references a shard outside, then you cannot scatter the query, right? Because it needs to look at data outside the current shard to be able to satisfy the current query. Or if there is a subquery that looks outside, right? So those are the kinds of dependencies that will not let you scatter a select statement. So basically, what you cannot do is you look at a select statement and say, oh, I don't know what the where clause is. I'm just going to send it to all shards. So that strategy will not work. You have to actually analyze the query and make sure that the correct result will be returned if you did a scatter. All right, so let's go to the next one. Now we are going to joins. So here's the join from two tables. We are joining on b.id equal to a.id, where a.id equal to 5. What should happen to this query?
This thing, I mean, don't we rewrite this so that you're actually getting, like, you're getting the rows from B where b.id equals whatever 5, like you said?
Well, let's look at it with instead of using A and B, let's look at it as with some real something that's more graspable by the brain. Let's say we have tables organized by let's say we have orders and items. Let's say A is order and B is items. And item table has order ID. Order has order ID and item table has order ID. And both order and item table are sharded by order ID. Which means that, what does that mean? So that means that all the items of an order are in the same shard as the order itself, right? Because they have the same sharding key. So if you try to describe this query, it's basically saying fetch all the items of order X. That's basically what this query does. So what would we do if we were an application and we had to run this query, right? So that's the question we are asking ourselves. And I would say, well, this is a single shard query, even though it's a join. Because for order ID 5, all the items for that order are in that same shard where order ID 5 is, right? So the right thing here would be, this is a single shard query. This query should be sent to the shard that contains that order ID. Make sense? Things are getting more complex, right? All right, now let's look at the next one. Oh, here's the more complex one. It's the same query, but there's no where clause. What should happen to this one? Well, if there's no where clause, which means that I cannot route this query to a single shard. The question that I have to ask myself is, can I route this query? Can I scatter this query? And the answer is, yes, I can scatter this query. The reason is because, like you said, the intrinsic property of the query is applicable to this because for any given order, all its items are in the same shard. Therefore, if you subsetted the query to just a smaller set of rows, you will still get the exact same result you would have otherwise gotten, which means that this query can be scattered. So far, so good. Let me know if I lose you. I assume that if you're silent, you are still with me.
Yeah, I'm just keeping the mic on mute.
Yeah. Oh no, feel free to ask questions. Yeah. All right. So these are what I call simple cases, and VTGate has to handle them. So in all these cases, VTGate should know exactly what to do with these queries. Now let's go to cross-shard joins. So here what we are doing is we are doing a join, but the join is on two different sharding keys. What that means is that if you find rows in A, the join condition says that the rows that have to be joined with A can be outside the current shard. So if this happens, then VTGate has to do the join. So if VTGate has to do two things. One is it has to break up this query into two parts, and it has to do the join. So the way it should do it is like this. The first query is select a.call. You drop b.call because b is from the second shard or second table. It has to fetch a.id additionally on top of a.call because that is the column that is used for the join condition. And then fetch from a. And then the where clause of a.id equal to id is part of the original query, which means that that is a single shard query. And then what we do is we actually then build a new bind variable called aid, which will feed into the second query. And the second query actually extracts a different part of the original query into a complete one, which is select b.call from b. But then the join condition is now here appearing as a where clause because there is no join here as far as SQL is concerned. And then it says b.id2 is the bind variables that is supplied by the first row, the result of the first query, which is aid. Does this make sense?
I have a couple questions. So one is just the rehash of this same question from yesterday. Like, really, this is fast? I mean, no, it's not fast. That's what you said yesterday. Is that like, okay, this can mean that you're now doing like 1,000 network hops.
Yes, it won't be fast if you are fetching thousands of rows.
Yeah.
But it will be fast enough if you are just fetching a handful of rows.
Yeah. And the second question is, do you really mean just cross shard, or do you actually mean like out of key space?
It is actually it is out of key space.
Yeah.
It can be a join. The second table could be in an uncharted key space, or the first table in an uncharted, or both. Any combination is possible.
Yeah, I mean, I think you just mean here that like these two things have like table A and table B have different sharding keys.
Yeah.
Which
actually they may be in the same key space actually.
They may be. Okay.
Yeah. They may be in the same key space, but they could be they are definitely in different shards. Because we are using a different sharding key here. So basically we are saying that B has two indexes, ID and ID2. And this time we are joining on ID2, which is actually not using the same sharding theme as A.ID. And therefore, those rows may not live in the same shard.
Okay. Yeah, I guess I thought that like a key space is essentially like the group of tables that all share the same sharding key. But
that's usually how you would deploy, but it's not a necessary condition.
Okay, a little more complicated than that. All right, thanks.
As a matter of fact, if you look at the examples under examples demo, we actually shard the lookup table too. And that key is a different key. So you can go and play around with that and see what happens. Because so basically you build a table, you build a lookup index, and then you put it in a lookup database, which is unsharded. And eventually, at some point of time, you realize that that is not scaling anymore because your database is so big that the lookup table is enormous. At that point, you have to shard the lookup table, right? So you shard the lookup table using the key that the lookup table has. And then you think, why should I have then a separate key space for that lookup table? I might as well put that table in my current key space. There is no restriction, right? In that case, now you are basically having a sharded database with tables that are sharded using different keys. And it could be confusing for somebody who is troubleshooting, but the system doesn't care. It will work correctly. As long as you give the query, it will go fetch the lookup row from one shard and then fetch the actual row from a different shard. Make sense?
Yep. Thank you.
All right. Here is another. Okay, so here actually, before going to the next one, so basically what we have done here is broken up this query into different routes. So basically, as long as we break up a query to the extent that a route can handle it, we build. So these are basically two different routes, and there's no restriction on what type of routes these are. Like the first query could be a scatter, and the second query could be an in-class, or vice versa. Or like you said, the first query could be on an uncharted key space, and the second one could be on a sharded one. So there is no restriction on what type of route each fragment of a query can use, as long as you can build one of those four routes that I talked about, which I'll summarize again later. As long as you can build a query that one of those four routes can perform, then you can perform any type of join. And as you can see, if there is a scatter query that joins with another scatter query, that is going to be obviously way, way more expensive than what you see here. So it all depends. The efficiency depends a lot on what these routes themselves do, right? Are they single shard routes, or are they themselves scatter or some crazy stuff? So here is a minor twist to the original query. It's a three-way join. And in the three-way join, A and B are on the same shard, and C is on ID2, which is a different shard, which is a different sharding key. So ideally, this is what should happen. We should send A and B to one shard, and then use that result to drive the second, to drive the query on C. The twist question is, what if it was A, C, and B joined this way? Ideally, if we are really, really smart, we should rearrange the join order and still do the right thing. But right now, VTGate doesn't do that. It says, well, you should have written your query well. You should at least know this much about your query. So, but yes, we can later add these types of optimizations. So we do expect the application to be slightly responsible when they specify join queries, at least specify them in a way that's easy for Vitess to break it up correctly. So I'm going to introduce a new rule called the rightmost route rule, which is an awesome rule that we discovered when we were analyzing how to handle routes. So here is a crazy query. You did a select A and B, and you have a crazy join condition that just makes sense. Can Vitess handle this query? Right? What the hell can we do with this query, right? If you specified something like this, the answer is actually very simple. This is how we do the join. So take part A, take anything that addresses only A and put it in one query, and take everything that addresses A and B, put it in the other query, and then wherever A is referenced in the second query, you put a bind variable in there, and the join will work. So in other words, we can handle joins of any complexity because we don't care, because the join is actually done by MySQL for us. And so this is what we call as the rightmost rule. So, and this doesn't work. This works not just for joins. This works for pretty much any expression anywhere in the query. So if you had a complex expression in the select clause, I would do the same thing. I would, if the select was A plus B in the A dot call plus B dot call, then I would just push that A dot call plus B dot call into the second query and send the value of A in as bind variable to the second select. And MySQL will do the work for us. So the simple rule is as follows, which is if there is an expression, if basically Vitess is going to break up a query into two parts using a join, then any expression that references multiple tables will be sent to the rightmost of the tables. And and at that point, those references to the original table become actually external references, and those will be converted into bind variables that will be supplied at runtime. And this is actually another reason why we can go pretty far with just routes and joins, because wherever possible, we can push down a lot of the work into MySQL itself. So you really have to have weird complexity in your query for Vitess to basically say, sorry, I can't handle it. And the only complication, as I mentioned, is if queries have to look beyond themselves and work has to be done beyond what that lookup is.
So, but this query here, the first one, from where it's broken up, that has no filter on the rows, right? That will be a scatter.
So the first one will be a scatter.
So we're
And
actually, I mean, writing a query like this, even if it weren't so like crazy. Well, no, I guess you're saying, yeah, if it has to be something crazy like this, that will scatter.
Yeah.
And then
one would not write a query like this in the first place.
yeah,
But one could have written something like select a.call, b.call, a join b on a.id equal to b.id2, and a complicated where clause that addresses that used both tables, right?
yeah.
So that where clause fragment can still be pushed down into the second query. So basically, VTGate doesn't have to give up saying, oh, I don't understand this expression, therefore I'm not going to allow it. Instead, it says, well, I'm just going to push this work down in MySQL and give it, supply the value so that it can do the work.
So when you execute that second query, are you executing it multiple times, once for each value?
Correct.
The first one?
Yeah.
So you don't put together like a bind list and send in an in clause or something?
Yeah, so that's an optimization that we talked about yesterday. You can, the current implementation does it one at a time, a simple nested loop join. But we can change it to a block nested loop join where you get a bunch of rows from the first table and then outsource the bulk of the work and then do a block nested loop join. So that is possible even though we don't do it yet. So this is mainly to illustrate that we can handle some really complex queries, even though VTGate itself doesn't do any work. Make sense? Optimizations aside, this is purely from can we serve this query? Yes, we can. It's going to cost you a lot, but yes, VTGate can serve this query. And obviously, if you are the application, you still have to use caution and know what is the actual cost you're incurring when you do these crazy joins. The philosophy is, well, if VTGate didn't do it, the application is going to do it itself. So such queries, we do it in VTGate for you. So that's basically how we look at this. And honestly, if a query like that came, a MapReduce job can totally do that thing for you, and it'll work fine. So if and when we get to the MapReduce version of VTGate, then these queries should run pretty fast because it'll be distributed and most likely also quite efficient. All right. So the next one is, let's see, what does this one do? Select A and B from A. So this is a cross shard join because B.id2 equal to A.id. And there is an inequality at the end. This actually is actually, I think I added the first example is a worse example than the second one. The second one is a more likely, is a more typical use case. The first one is to just show how we handle expressions of arbitrary complexity. The second one is an example of if somebody had sent a query and there was an inequality in the where clause that referenced both tables, how would you handle it? It's the same rule that we applied to the first one. All right. And like I mentioned, this rule can be used for all constructs. And you'll see that in the code that it's actually one function that handles this rightmost rule for all constructs, which is kind of cool because that makes the code really, really compact. And finally, last but not the least, is cascading joins. So here we have A, B, and C joined on different sharding columns, and VTGate can do cascading joins. And obviously, it will be very, very inefficient. Nevertheless, it can do. The core functionality is there. It is up to us to figure out how to optimize it. So as use cases come in, if you start requiring use cases where you have to do these joins, and you do have to fetch a lot of rows, we can go in and optimize that part of the code. Actually, I can show you the join code. It's right now it's about maybe 100 or 200 lines. That's about all there is there right now. And if you expand it to do block nested loop joins, it should be fairly easy to add that part over there. What else? There are other constructs here. Here is another one. So basically, we have looked at crazy where clauses, crazy on clauses. How about subqueries? Here is a correlated subquery. You have a subquery inside B that says B.id is equal to A.id. What that means is that the rows in that subquery depend on the sharding key of the rows of the outer query. And this is no different than a join on the same sharding key, which means that this query can be sent to a single shard. And VTGate can do that for you. How about this one? Select A, B, C from. Oh, this is there's a mistype here. I should. I don't know what I meant by this. I think this query cannot work.
Well, how is it a mistype? It's
count star C. C is an alias.
yeah.
Okay. Yes.
Yeah, the whole subquery is A. The count is C.
Yes.
Yeah. This is fine.
Yeah. So here, I think what I'm trying to say is, this is really awesome. I didn't know I did this, but it looks like I do. So basically, the subquery is actually inside a from clause, and it is selecting ID and count star. So to answer the question as to why this is even a single shot query is because of actually the join condition that says B.id equal to A.id, and that join actually applies to the inner table, and because of that, VTGate figures out that it's the same shard. And that there is a join after that on B. So I need to go look at, I need to go study this myself. But basically, I think it comes from the fact that when you do the sub-select inside that, and the fact that the subquery table has ID in its column, means that that becomes a table that itself inherits the underlying Vindex, and the subquery becomes a Vindexed table, and therefore the subquery acts as a sharded table itself with ID as a sharding column, and therefore all the rules of a sharded table apply to that subquery, and therefore it can be executed within the same shard. I don't know, did I make sense at all? So this is basically inheritance of the sharding key. Basically, the subquery is inheriting the sharding key of the underlying table because of the fact that it selects it on its select list. The short answer is hopefully you don't write such complex queries, but if you do, VTGate will know to do the right thing for it. And here is a simpler one of this, which is select ID, count star from A. This query can be scattered. The reason is because the sharding key is in the select list, and therefore there is no cross-shard dependency while doing this aggregation. You only need to look at rows within the single shard to perform this aggregation. Make sense?
No, not really. So on for starters, right? This is not. Well, maybe it is standard SQL, but just forgetting about Vitess for a second, on MySQL, this returns. If you have a table with whatever 10 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's going to return to you 1, 10, 2, 10, all the way through 10, 10, right?
Well, look at it as a query on the items table, right? So basically, you want to see how many items in each order.
Yeah, but there's no group by.
Oh, sorry, I just mistyped it. Let me fix that right now. So group by ID. There you go. Now what you say? Sorry.
I was gonna say, like, what? Do you maybe mean that in the same thing above as well, in the subquery?
Yeah, I probably need that in the above query. So I'll fix that in the slide later.
Okay.
Yeah. So if it is group by ID, yeah, you're right. Yeah, this is what I meant. I have to probably fix the source where I copied this query from. So in this case, it will. So we are basically counting all orders and the number of items they have. So basically, I want a list of all items and their orders. The number of item count for each order. Basically, that's what this query is. So it's a legitimate query. It could be used quite frequently. And in this case, the query can be scattered because the sharding key is in the select list. We know that there is no cross-shard dependency in this case.
Okay, yes, now that's clear. Before.
Sorry, select, what is this one? Select from, here's a crazy query. It's a join, and there's an order by.
And a typo.
And a typo too? Where is it?
A join B.
A join. Ooh, B.
We know what you're saying.
Yeah. Read it like it's spelled. There you go. Okay. Fixed. So, in this case, we are doing a join A and B on. In this case, I use b.id equal to a.id, which is itself incorrect. It should be b.id 2, right? There you go. So, because if it was a.id equal to b.id, it would become a single shot query. So in this case, actually, we can push the order by to the individual routes because the order of the order by routes matches the order of the join, and therefore those order by clauses can be split, and the outcome will still be the same. This is actually the part that Amit actually changed recently with the order by, right? I remember you changed something in there. So
you're saying if it were actually order by b.id2, a.id,
it will reject it. It will say, I don't know how to, this query is too complex because I have to then do the order by.
I see. Yeah, the complex order by. Yeah.
So as long as the order by order matches the join order, you can actually break that up into the different fragments. Because if you join them, because the original query is coming in the correct order and the second query is coming in the correct order, and therefore if you join them, the outcome will also be in the correct order. Oops. All right. I think we are reaching the end. It's 3:05, so let me see if we can. We should cover this. We can cover this as the last slide, and then we can stop for today. So the next question is, how much of the schema should VTGate know in order to satisfy your query? This would be a somewhat controversial question. We have ourselves debated this a lot. The basic question is an SQL query self-describing? And the obvious answer is most of the times yes, but sometimes no. Especially when it comes to join, when you do select star from T1, T2. If you knew the schema, you would know what to do with that query. But if you didn't know the schema, then you'd be totally confused. So the one rule for now that we have on VTGate is that the query, ambiguous queries that require schema knowledge are not supported, which means that if you had a select star from T1, T2, you are expected to rewrite it as select explicit columns, and then from T1 and T2, and the columns have to be qualified by the tables, because otherwise VTGate doesn't know which table you are referring to. But if you have a single table query, then obviously VTGate can figure out that they all come from the same table, so there's no problem. So it'll auto-resolve those. You have to be careful about the auto-resolve in the case of a subquery, because a subquery has scoping rules. So in this case, for example, if you used a select B from T1 where ID is equal to A, we don't know whether the A comes from T1 or whether the A comes from, refers to the A that is in the outer query. In this case, actually, this could be a very good trick quiz question. In this case, actually, the outer A is not visible because of the fact that it's in a where clause. That's an interesting thing we can talk about when we do, when you look at simple table resolution. But if this was a having clause, then the A from the outer query would be visible in the subquery, and therefore there is an ambiguity. And I think the way MySQL resolves it is because it knows the schema and it knows that there is no A column in T1, it will resolve it with the outer queries A, whereas VTGate doesn't know that, and it'll probably think that it belongs to T1, and you'll basically end up with a syntax error. But the way to resolve it is you say ID is equal to T.A, and then everything works. So this is a topic that keeps coming up. So I think we are now at a point where we think that we will eventually have to make VTGate aware of the entire schema. And once we cross that bridge, all these issues should be taken care of. So until then, some of your queries. Yeah?
We'll have new issues.
Yes, you have new. So the reason why we wanted to avoid this is because of operational simplicity. Because VTGate doesn't know the schema, that is one less operational overhead for you, because if you update the schema, then we need the workflow to make sure that that schema change is reflected for VTGate, right, for it to work. And you have to handle the case where a schema is currently being deployed, which means that some shards will have a column, some shards won't have a column. What should VTGate do in such cases? So all those issues have to be resolved. But we know how to resolve them, but they just have to be worked through. So once we work through all that, then this should work. Then VTGate should work like a tradition, should understand your query as intelligently as MySQL would.
And so this kind of thing with the select star from T1, T2 is not just handleable, but I mean, I know there's this this thing, the impossible query, the fields query.
Yeah.
We can't handle this kind of thing with that?
Oh, you mean run the query and then get the schema?
Yeah, or like when
I mean, there are ways to fetch the schema, but the issue is more with how often do you run that, and what if how do you manage notification? What's the workflow? What if some schemas have it, some don't, right?
I see. Okay, so it's yeah, that part of it is there. We haven't done all of this stuff. Also, it's a little typo, right? Select a.t1. You mean like t1.a, I guess.
Yeah, I think that's a typo.
T1.a, yes. Yeah. Oh my God.
Oh, that's okay. It's okay.
I will review both this and the previous slide. I think they all have lots of typos. And I should also review, I pasted, not this one, but the previous ones I pasted from the design doc. So I may have to fix that part also. Cool. So let's see.
So I have a question around VTGate's VTGate aware schemas. So with that being said, then would we be able to at all have the schemas applied only to certain shards and not applied to all the shards? Wouldn't that cause an issue or something, or would it?
Oh, I guess the question is, why would you want to do that? Because a sharded key space is a single database with is logically a single database using a single schema, right? Like if all those rows were in one database, would you even be able to do this? You see what I'm saying?
Yeah, I understand what you're saying, but like an example would be that we need to enable a feature or disable a feature only for a certain set of customers, or maybe certain set of shards potentially, and
So it's for more the multi-tenant use case.
Yeah, for the multi-tenant use case, that might be helpful.
Yeah, I would say it would probably be a Pavel question. From the query routing perspective, Vitess doesn't really care, right?
I mean, there are other ways to handle that. As to at the application side, we can always handle those things, but yeah.
Like, don't do crazy stuff where column types are different. That will likely mess things up. But if you, like, for example, had I don't know, like the size of a var binary, for example, right? If you make it smaller on one and bigger on the other, and that kind of stuff, I don't think Vitess cares about those things.
Okay, got it.
The part I would say would be the part where it may affect is if VTGate starts to do more operations, starts to implement more of those 8 primitives. You have to be aware. You have to basically wonder if the different schemas will affect those operations, right?
Right.
Like, for example, if you use different collations for each of those tables.
Yep.
And then you do a sort at the VTGate level. What would be the outcome, right? So there are some weird things that could happen that you should be careful about.
Yep, I agree. All right.
Cool. So we'll stop here today. So we are still on schedule. This is exactly what I wanted to cover because the next session is going to be really, really hardcore. So, which basically is going to talk about how exactly VTGate is going to make all these things that were easy to explain and intuitively understand. VTGate has to actually make it happen in the code. And what algorithms it uses basically is what we will cover next time. And if we get past that and come out alive, then we should be good. All right. So I'll see you all tomorrow.
Yeah. Is there any objection to bumping it up an hour tomorrow?
Like 1 to 2?
Yeah. Would that be okay?
Tomorrow is Wednesday.
It is?
Yeah, I can do 1 to 2 tomorrow.
Okay, thank you.
Yeah, so I'll schedule it for 1 to 2 tomorrow.
Okay, great.
1 to 2:30 because we may run over a bit.
Yeah, apparently. Okay, thank you very much.
Cool. See you tomorrow.
Thank you. See you. Bye-bye.